Hello, we're Adam.
I'm Colin.
And I'm Nick, and we are modeling Starbucks at Campus Market for our IME 420 project. Our objectives mainly are to improve the customer experience of Starbucks as well as the operational metrics. These metrics involve customer queue time, time and system, and revenue. To do so, we're going to be planning to run three main experiments. The first one is a few proposed line rebalances. So, is moving, for example, a barista or two from one of their slower afternoon shifts to a busier morning shift. How is that going to affect time and queue, operational cost? How will this affect revenue? Other things that another experiment we're trying to run is the promotion. For example, how would a few promotions that maybe are working at the other Starbucks, how will this affect their bottom line? And with all this increased throughput, will this cause extensive queue times so that they're losing money? Our third experiment is many restaurants are going towards online ordering. If this is implemented, for example, will freeing up this cashier time actually increase the overall throughput and thus revenue?
So Darcel is the name of our branch manager at Starbucks at Campus Market, and she is our primary contact for this project. She sent us data for the 2015 year, and this data includes sales revenue per order, items per order, timestamps for each order, and cashiers that were on site during each order. With this data, we can accurately compile arrival rates across different time windows during business hours across the week. We plan on computing arrival rate distributions for each half hour because the arrival rates will vary depending on the time, given that there are classes starting at the top of each hour or at 40 minutes past each hour. And we are doing this only for weekdays because weekend arrival rates will change drastically compared to weekday arrival rates. Additionally, we will collect data on processing times for our two separate servers in the model: standard coffee drinks and specialty beverages. To do this, we will spend 12 man-hours recording processing times for each service operation. We expect that the coffee service times will have a lower variance since there is less variability in the process and it is the same each time.
So now we're going to walk you through the logical model. So first you'll see the source, and most of our data for arrival rates is supplied by the branch manager of Starbucks. We're using arrival rates and timestamps on sales data to determine which distributions fit the arrival rates best. So that queue at the cashier can be very large or very small. Additionally, there are only two registers, so the capacity to handle customers at the cashier step will be either 1 or 2. Now from that point, we have our two entities which are either separated depending on what happens next. If the customer orders a regular coffee or decaf coffee, for example, they will go straight to the exit with their order. They've already received it. If they order a specialty drink, frappuccino, a latte, americano, they will then go to a waiting queue and their order will be processed by the baristas. Now this step has a lot of variability, and the capacity changes based on the staffing that is applied to that particular moment in time. Now each customer is waiting in queue, and then eventually once the order is completed, the proper order goes to the right customer, and then together they are joined and they move to the exit. And at that point they are exiting the system. We have options of the exit simply being the immediate Starbucks vicinity or the actual exit of Campus Market. So we can include travel time for each of those steps if we absolutely want to.